Conduit fill is a crucial aspect of electrical installations governed by the National Electrical Code, or NEC. Understanding the rules for conduit fill, especially in situations involving short conduit runs, is essential for safe and compliant wiring. The primary guidance for conduit fill is found in Chapter 9 of the NEC. This chapter provides tables that specify the maximum percentage of cross-sectional area of a conduit that can be occupied by conductors. These fill limits are designed to ensure adequate space for heat dissipation, prevent damage to conductors during installation, and facilitate future modifications or additions to the wiring system. Typically, a maximum fill percentage for conduits containing 3 or more conductors is 40%. This means that the total cross-sectional area of all conductors within the conduit cannot exceed 40% of the conduit's internal area. However, there are exceptions to this general rule, particularly for short conduit runs, also known as nibbles. NEC Section 310.15 Exception 3 addresses the ampacity of conductors in short sections of conduit. This exception allows for higher conductor ampacity in certain situations where the conduit length is limited to 10 feet or less, and the conductors are not bundled for more than 24 inches. The purpose of this exception is to recognize that short conduit runs have better heat dissipation characteristics than longer runs, allowing conductors to operate at higher temperatures without exceeding their insulation rating. This exception does not directly address conduit fill, but it is often considered in conjunction with fill requirements for short runs. When dealing with short conduit runs, it may be tempting to exceed the 40% fill limit, especially when working in tight spaces or when the number of conductors is high. However, it's important to carefully consider the potential consequences of exceeding the fill limit even in short runs. Firstly, exceeding the fill limit can make it difficult to pull conductors through the conduit, potentially damaging the insulation and reducing the lifespan of the conductors. Secondly, overfilling a conduit can restrict airflow and reduce heat dissipation, leading to higher conductor temperatures and potentially increasing the risk of insulation failure or even fire. Thirdly, exceeding the fill limit can make it difficult to add or modify wiring in the future, as there may not be enough space to accommodate additional conductors. In situations where exceeding the 40% fill limit seems necessary, it's crucial to evaluate the specific conditions and make an informed decision based on sound engineering judgment and the applicable code requirements. Factors to consider include the length of the conduit run, the number and size of conductors, the ambient temperature, the type of insulation, and the potential for future modifications. If the conduit run is truly short, and the conductors are adequately sized for the load, and the ambient temperature is within acceptable limits, it may be possible to exceed the 40% fill limit without compromising safety or performance. However, it's important to document the decision-making process and obtain approval from the local electrical inspector if required. When working with numerous knockouts in a panel or enclosure, it can be challenging to install conduits of the appropriate size and maintain adequate fill. In these situations, it may be necessary to use a combination of different conduit sizes and types to optimize the wiring layout and minimize fill. It's also important to carefully plan the knockout locations to ensure that there is enough space to install the conduits without overcrowding or damaging the panel or enclosure. In some cases, it may be necessary to use offset connectors or other fittings to route the conduits around obstructions and maintain proper spacing. When dealing with existing panels or enclosures, it's important to inspect the condition of the knockouts and ensure that they are properly sized and aligned. Damaged or misaligned knockouts can make it difficult to install conduits and can compromise the integrity of the enclosure. If necessary, damaged knockouts should be repaired or replaced before installing any wiring. The NEC provides detailed requirements for conduit fill in Chapter 9, along with various tables and examples to illustrate the application of these requirements. These tables specify the maximum number of conductors of a given size that can be installed in a particular size of conduit, based on the type of conduit and the type of conductor insulation. To determine the appropriate conduit size for a given application, firstly, identify the number and size of conductors to be installed in the conduit. Secondly, consult the appropriate table in Chapter 9 of the NEC to determine the maximum number of conductors allowed in each size of conduit. Thirdly, select a conduit size that can accommodate all of the conductors without exceeding the fill limit. It is also important to consider the type of conduit and the type of conductor installation when determining conduit fill. Different types of conduit have different internal diameters, which can affect the amount of space available for conductors. Similarly, different types of conductor insulation have different thicknesses, which can also affect the fill calculation. The NEC provides separate tables for different types of conduit and conductor insulation to account for these variations. In addition to the fill requirements in Chapter 9, the NEC also includes other requirements related to conduit installation, such as the minimum bending radius for conduits, the spacing of conduit supports, and the grounding and bonding requirements for conduits. These requirements are designed to ensure that conduits are installed in a safe and reliable manner and that they provide adequate protection for the conductors they contain. When installing conduits, it's important to use the correct tools and techniques to avoid damaging the conduit or the conductors. Conduit should be cut squarely and deburred to prevent sharp edges from damaging the conductor insulation. Conduit bend should be made using a conduit bender to avoid kinking or flattening the conduit. Conductors should be pulled through the conduit using a pulling lubricant to reduce friction and prevent damage to the insulation. When making connections to conduits, it's important to use the appropriate fittings and connectors to ensure a secure and watertight connection. Fittings and connectors should be properly tightened to prevent loosening or corrosion. When installing conduits in wet or damp locations, it's important to use watertight fittings and connectors to prevent moisture from entering the conduit system. The NEC requires that all electrical equipment and wiring be installed in accordance with the manufacturer's instructions and the applicable code requirements. Failure to comply with these requirements can result in unsafe conditions and potential hazards. It's important to consult with a qualified electrical contractor or engineer to ensure that all electrical installations are performed in a safe and compliant manner. In summary, understanding conduit fill requirements is crucial for safe and compliant electrical installations. While the 40% fill limit is a general guideline, exceptions may apply for short conduit runs. Factors such as conduit length, conductor size, ambient temperature, and potential for future modification should be considered. When working with numerous knockouts, careful planning and the use of appropriate fittings are essential. Always consult the NEC and local electrical codes for specific requirements and consult with a qualified professional when in doubt.